Welcome to another class of computer network. Till now, we have seen the classification of classful addressing of IPv4. So we have seen all the classes from class A to class E, and now you can see that only class A, class B, and class C can be used for the purpose of distributing IPs for general purpose, because for the class D, if we talk about class D and class E is reserved for the special purpose, and where class D is used for the multicasting purpose. Meanwhile, we have also discussed the unicasting and the broadcasting. You have till now you may be familiar with the unicasting and broadcasting. In broadcasting, there are two terms: limited broadcasting and directed broadcasting. So, as of now, you are familiar with all the terminologies. Now we will go further in the network and we'll see how the IPs are being distributed. So you can see, let's say, if you want to configure a network, or you want something that you require certain number of IPs. For example, let's say if you own some company, or if you have your own set of office where you want the uh, your own IPs you require. So you have to purchase the network part, or you can say the net IDs you have to purchase, and then the remaining you can configure. Let's say what I'm trying to say is, I'm just trying to say is network part, or you can say the network ID part. You have to we have to purchase. Okay, and there are internet service provider which जो कि हमें यहाँ पे ये सब when you are trying to purchase some network IDs, then they are going to assign you. Okay, now let's say for example, if you have a requirement of in total greater than 2 raised to power 16 number of host. Okay, by host I mean the certain number of users are in your network. Then you have to buy the class A IP address, and let's say, so this is the LAN 1 if I say, and you have bought class A IP address. Let's say it is 10.0.0.0. Here you can see this 10 in the if it is a class A IP address, then it is the first octet is nothing but the network ID, and rest 24 bits are given for the host ID. Okay, in this case, as we have discussed in the IP, that this 10 dot the first IP which is given for the network, that is 10.0.0.0. So you can see this is the IP of the network, where all the host part is 0, and the network ID part is something what you have purchased. Now you can assign the host by giving different out of these 2 raised to power 24 IDs you can give to each number of hosts. For example, let's say if you have one user over here, then you can give 10.0.0.1 over here. For another user you can give 10.0.0.2. Similarly, let's say it is 10.0.0.3. Okay, and so on, like this. And then this network is connected to a router, and as I already told you, that router has the number of interface, उतने ही उसमें इंटरफेस होंगे जितने नेटवर्क से वो कनेक्टेड है. फॉर एग्जांपल, इफ दिस राउटर इज कनेक्टेड विद टू नेटवर्क्स, let's say this is another network, and let's say if there are two networks the router is connected to, so one interface this and another interface is this. That means हर एक इंटरफेस जो राउटर के होंगे उसका अपना एक मैक एड्रेस होगा और उसका अपना एक आईपी एड्रेस भी होगा. Okay, so here one IP address is being assigned for this. So as of now I'm just writing randomly. In general, this dot one is given to the for the router, and the rest are distributed among the users. But just for the just for the knowledge purpose, you can assume that anything I have given over here. Similarly, here, let's say there is a requirement of less than 2 raised to power 16 number host. Okay, then you may go for class B. Okay, you can go for class B over here, where now assume that you have bought 128.1 as your network ID part, and rest are 0, which are your host ID part. So this is what the network ID part, and this is 16-bit are for network ID and 16-bit are for host ID. Now, one IP should be given for this interface of router, and let's say that is 128.1.0.1. What I was talking about in general, this dot one is given for the router that is connected to a network. So this is something, but this there is no specific rule, but in general what is being followed is this. Okay, so now you can give IPs, different IPs to the different host. For example, you can give to this host 0.2, one you have already assigned. Now you can give 0.3, you can give 0.4, you can give. Okay, so now you can see over here that we have purchased. If we talk about this network one, if we talk about, we have only purchased the network ID, which is 10. Okay, and rest host IDs are nothing but 0.0.0. So this is what the IP address of network, and this is network 1. So this is the IP address of network 1. Okay, and then you can see that means this 000 is given for the net IP, given for the network. And you can see that, let's say, for the how these IPs are distributed, you can see over here in the next page. You can see, so 10.0.0.0, here you can see in the host part. Okay, if there are all zeros, so host part are all zeros. That means if it is so in any IP address, then that kind of IP address is the IP address of network. Okay, or simply we can also call it network IP. Okay, this is the net ID part, this is the host ID part. So all host IDs are zeros. Now if we talk about the that means we can say that this IP address 10.0.0.0 cannot be assigned to any host. Now we can see that how it is being assigned. So 10 is remaining as it is. So now we can we can distribute for the further octet. If I write it, so this is the second octet, third octet, fourth octet. Okay, so this is I have kept it. You can also write it in binary, and if you write it in binary, you can see it over here. This would be 0 0 0 and then 0, then 1 0 1 0. This 0 is fixed as it is a class A IP address. Now just because we have purchased it, this is not going to change for the assignment of any IP address to any host. Okay, so this will remain, as it is. We cannot change, so this can't change. We have bought it. Now this all zeros part will be given for the IP address of network, so that is also we cannot assign to any host. Now we can assign 0 0 0 0 0 0 0 to, let's say, host 1. You can also give to the interface of router. Okay, and similarly, 1 0 1 1, then 1 0 0, and like this. And so on. So this is how you can assign the if I put all one here, similarly where these are all zeros, similarly if I go further, so the time will come when we'll have all ones, then here also we will have ones, and we will have all ones here, and we will have all ones. This is something what we store for. This is something what is 10.255.255.255, and this is the IP address for the directed broadcasting. Okay, so this is also we cannot assign to any host. Okay, and that means we can only assign till 10.255.255.254. We can assign this much of last IP address to any host. So you can see from this host 1 to this much we can have 2 raised to power 16 minus 2, which is 1, sorry, 2 raised to power 24 minus 2, because there are 24 IDs for host part, and out of those we have removed only 2. That is one that is reserved for IP address of network, and another one is that is used for the broadcasting purpose. Okay, so this is the IP address of directed broadcasting. Okay, and this is the IP address of network. So now you can see that in total we can assign to 24 minus 2. This minus 2 is, one is this, another one is this, and this 2 raised to power 24 are all the IP address that you can generate through this 888, and that means in total 24 IDs, 24 bits, and out of 24 bits you can generate 2 raised to power 24 addresses. And this is how you can assign the IPs to any host. Now similarly, if we look at the network 2, what we have seen here, and network 2 was 128.1.0.0. This was the IP of the network, and similarly this is something we cannot change, so this will remain same, 128.1 dot, and then if I fill it all these 88 bits with all ones, then that would be 255.255. so this would be the directed broadcasting address, you can say, and in between these will be your host. Okay, so there is one thing that you can see, that if all host part are 0, then that would be an IP address of network, and if all host part are 1, then that would be a broadcast address. Okay, so for network IP, how you can see by looking at any IP address. So for network IP, there is something host part should be 0, all zeros, okay. And for broadcasting, this is directed, I'm writing the acronym for directed broadcasting address, okay. For this directed, if I write it over here also. So directed broadcasting address. So for directed broadcasting address, you need host part should be all 1. That is, if I fill it all by all 1, that will give you 255.255. And this is something which was network ID part, which we cannot change. Now we will see that you have seen in the LAN 1, or you can say in the network 1, there were 2 raised to power 16 hosts, okay. But we don't want a very big network. For example, let's say as we have seen in the network 1, we have assigned a class A, and the class A purchase will give you know give us the facility of serving 2 raised to power 16 million, sorry, 2 raised to power 16 host, which would be approximate to 16 million host, okay. And in any network, this much number of host are very rare to have. So we need a requirement of dividing a network into its sub network. So the reason is, first reason is, if we have a large number of hosts also, then maintenance of these IP would be very difficult, okay. And you can assume that if there are this would be approximate 16 million number of hosts. So if you have to maintain the 16 million number of hosts at a time, then it would be a bigger task, or it would be a challenging task. And the second thing is, that is something what we deal with, the security. So let's say we have a university IP we have assigned, we have given one IP for the university, and that university has 4 departments. One is maths department, another is computer science department, let's say third one is civil department, and then this is mechanical department, okay. So let's say in that university or in this college, uh, there is one math server over here, and we want that only maths faculty or maths student should access this math server, and we don't want anyone to access any common server. So we don't want that computer science guy can access this math server, or mechanical guy or civil guy, because there is no use. So we, for the security reason, we only want this server to be accessed in this limited region, which is the only mathematics department. So for that, you can understand, we cannot we don't want the network to live loosely, or we cannot open this math server for everyone. So for that also we require the subnetting, where this whole network, okay, will be divided into 4 subnetworks, okay. Now if we talk about, these are the advantage of subnetting. Now if we say that what is the disadvantage of subnetting, so you can see there is very simple, or you can say not a major concern of this major type of disadvantage. But yes, if we say, so you can see in the process of, let's say this is a network. Now in the process of when a packet come for the network, so what it has happened from the external router, first step is to find out the network, okay, for which network the packet is destined to. Then second step is you have to find out the host to which host this packet is destined to, and then third is once you reach the host you have to find that to which process this third step is which process, okay, this packet is should be destined to. Okay, so if we do not have any kind of subnetting, then we need three steps to reach to send a packet to the destination. But if we have subnetting in the network, okay, so let's say if we have subdivided this network into four parts, then one step is being increased, and that is first, in the first step that packet will come to the network, and in the second step you have to find the subnet for which subnetwork the packet is destined to, and in the third step you have to find the host, and in the fourth step once you find the host, in the fourth step you have to find the process which process the packet is destined. So this is the only you can say the disadvantage of subnetting, that one more step in identifying the packet, or you can say in transmitting or in sending the successfully a packet to the destination. Now we will see the subnetting in detail.